Right, let's just go and make another change to this event structure. Actually, wait, last time I did this, I caused a lot of issues to that other system. So actually, maybe I just give them a quick call first.
Hello?
Hey, how's it going? It's James from the Orders team. Yeah.
Yes.
So remember last week when I made that change and when I caused you a whole lot of pain and your alert went off and you couldn't finish your book and all of that stuff?
Yes, I do
Yeah.
actually. Yeah, that's kind of
Yeah,
annoying.
well, I might need to make another one, unfortunately.
Well, is it actually going to be a breaking change? Is it actually going to break
Yep.
my system again?
Well, here's the thing. I don't actually know if it's going to be a breaking change. I don't actually know. We don't actually have a way to test if the thing we do is actually going to break a system.
Have you ever considered schema or contract testing, like writing a test in your system to actually make sure that you aren't going to break my system again? Hello? Anybody there?
Yeah, that's a pretty genius idea actually. I don't know why we've never thought of doing that in the first place. Thanks.
Hi, I'm James Eastham, and in this video, you're going to learn all about the power of schema and contract testing. When you're building an event-driven system, the events you publish are the API of your system. And of course, as much as possible, if you were building a synchronous API, you'd want to avoid making breaking changes that would affect the people who are calling your API. Well, means for an event-driven system, you want to stop making breaking changes there as well. But how can you do that as a producer? If you've got lots of people working on your team, all contributing or working independently, there's no easy way to make sure that every single code change doesn't actually make a breaking change. Unless, of course, you've got schema and contract tests. Schema and contract testing is a way of taking the schema that you expect an event to have, typically you would define that in some kind of JSON schema, and compare that to the event that your system actually publishes. So you're going to run some business logic, get the event that business logic generates, serialize that down to a JSON string, and then compare that JSON string to an expected schema. This is a really flexible approach because if you make a breaking change to that event that then doesn't match the schema, your test is going to fail. But if you make a change that was to, for example, add an additional property, well, that's not a breaking change, which would mean the test would then still pass. So you're preventing yourself from making breaking changes while still giving yourself flexibility to evolve the system as and when you need to. How would you do that? Let's go to the desk and have a look.
Okay, so let's talk about schema and contract testing. How exactly can you write tests that test the schema and the contract of your events? And one of the ways you can do that is simply using unit testing frameworks. So if you have a look at the plant-based pizza code base and you go and have a look under the plantbasedpizza.orders project into tests and into unit tests. And inside the unit test project, you've got this whole category of schema tests. Now in the .NET ecosystem, we're incredibly lucky because we've got a library called NJSON schema. And NJSON schema allows you to compare a JSON schema to a JSON string and check to see if the two match. So that's exactly what you're going to do here. You're going to run a piece of business logic, grab the event that gets generated, serialize that to a string, and then compare that to an actual JSON schema. So if you look at the actual test that's happening here, this first test, let's just take one of these examples. When an order gets created, the order created event should be generated and the V1 schema should match the definition. In this instance, there are two different versions of the order created event in play. Here, you're testing version 1. And to do that, you're actually going to run the business logic of your application code. So the way all of the events work inside Plant-Based Pizza is that the events are collected up as a list of events against the actual object itself. And when the object is persisted to the database, all the events are then written to the outbox table in the database. So whilst the business logic is actually running, all the events are just being collected up in this in-memory list of events. So when that order.create method gets called, this is going to validate the properties that were passed in, generate a new order identifier, create a new instance of your order object, and then you'll notice here it's going to add a new order created event to that list of events that are in memory. And because there's two versions of the events in play, we're going to add both version 1 and version 2 of the order created event. So at this point, you've run your business logic that will always happen when an order gets created, and now you've got two events in memory inside this order object. Your test can then look at that list of events and check to see, first and foremost, that the order created event has been generated and that it is version 1. So you're checking that inside that list of events, there is a version 1 of the order created event. You'll notice if you look at the second test down, there's the exact same thing happening here, but looking for order created version 2. So you're checking in two separate tests that version 1 and version 2 of the event are generated. You're then going to take that event that gets generated and serialize that down to a JSON string. So now you've got a JSON representation of your actual event, the event that your business logic has actually generated. You can then use the NJSON schema library to load a JSON schema from the local file system. And you'll notice under this expected schemas folder, you can see all of the different JSON schemas. So for version 1 of the order created event, you expect there to be an order identifier property that is a string and it is required. So you're going to load that JSON schema up. Then you're going to use this validate method on the JSON schema. The validate method takes a string and you're going to pass in the actual JSON representation of your actual event that was published. And if there are any mismatches between the event that was published and the schema, this validation results will return some values. Here, there are no errors with the schema, so my validation results.count should be 0. If you go off and actually run this first test now, this will pass successfully because, of course, the event at this moment in time matches the schema that you expect. Let's actually test this now. Let's actually see if this works. So I'm going to go and open up the order created event. That's held under the public events folder, and we'll look at version 1 of the order created event. And I'm actually going to change this to be order ID. I'm going to use the quick refactor features in Rider to refactor that to order ID. So now the property in my application code is called order ID. And after I make that change, my code will compile. If you go and build your actual orders API and run that build, this is going to build because, well, code is valid. You've changed the name of a property. All the code inside the order service is using that new property name. Everything seems okay. But if you actually come back to your tests now and rerun that same schema test, this time your test is going to fail. It's going to fail because there are some validation errors. There's a difference of 1 because you've got a validation error now, of course, because you've just broken the event schema. So that's a really quick look at schema and contract testing. One thing I would recommend doing if you're going to start doing this is to make sure you run your actual business logic. Don't just create a new instance of your event. Run the actual business logic that's actually going to generate the event and use that to test against. Serialize your code down to a string and use NJSON schema to validate that the schema of the event matches the schema that you expect. And if you need to create a new version of event, well, you create a new schema definition.
So, schema and contract testing. I hope now at least you're sold on the idea of at least giving this a try. It's a really low impact way of helping you prevent breaking changes happening to the events that your system publishes. You can run these tests quickly, you can run them locally, you can iterate on your system really quickly, making a change, running the test, and ensuring that you don't break the contract of your system. Remember, the most important responsibility you have as a producer in an event-driven system is to try to prevent breaking changes from happening. Just stick to the contract of the schema that you agree on when you started publishing that event. So making that requirement as strict as possible in your system by defining tests that test the contract of the event you publish, genuinely, it's a pretty sensible idea.